All right, hey everyone. Today we are going to do some simplifying exponents. It should be a pretty quick day. We're just going to go through the rules of exponents and then we're going to do a couple simplifying problems, and that's kind of it for today. So it should be a short video. We'll see if I talk too long or not, but I'm going to try and keep it brief. All right, so here we go. Here are our exponent rules. Now, every year that I've taught Algebra 2, which I didn't last year, but I did the year before, this gives students a hard time every year. They don't like their exponent properties. They're a bit tedious, so I kind of understand a little bit, but we definitely have to make sure that we understand our exponent rules this year because we do use exponents all the time. All right, so first rule that we have up here is something to the power of 0. So if you have 0 as an exponent, it is always just 1. All right, so giving a number example, because sometimes numbers help. All right, so if I had 100 to the power of 0, guess what that equals? 1. Anything to the power of 0 equals 1. Okay, the next rule, which we kind of touched on a little bit in our radicals video, is when you raise an exponent to another exponent. So in here we have, if you look at the notation, we have a to the power of m raised to the power of n. Anytime you do this, what you're going to end up doing is multiplying your exponents to each other. So if I were to have x squared to the power of 3, I'm going to multiply those two exponents. So that's going to give me x to the power of 2 times 3, which is x to the power of 6. All right, so when we were solving in our last video, we had things like this, right? We had like x to the 1/2 to the power of 2 over 1. And the reason why we're allowed to say, well, that cancels out is because when you multiply 1/2 times 2 over 1, you get x to the power of 2 over 2, which is x to the power of 1. So you end up with just x. All right, so that's a really important property. Just remember, if you're raising it to raising a power to a power, you multiply. All right, so that's that property. The next one is the negative exponent property, which people also don't like to do. But if you see a negative exponent, if you want to make it positive, you do what's called the reciprocal, meaning you flip it upside down. All right, so if I had x to the power of -3, and I wanted it to have positive exponents, because generally when we want something in the most simplified form, we want it to have positive exponents, I would rewrite it as 1 over x to the positive 3. All right, and the same thing goes if the negative is on the bottom. So if you started out with 2 over x to the -1, if that was your original problem and you wanted to put this in most simplified form, what you would do to make that -1 a positive is you would flip it to the top. So this would change to 2 times x to the power of +1. All right, now a side note, if there is a coefficient, like a number out front, so let's actually say, let's not like this problem. Maybe we don't like this one. Maybe we want to do another one. If we had, let's say 1 over 2 to the x -1. So now the 2 is on the bottom with the x, and we have that -1 exponent there. So say this was our problem. All right, what a lot of times students want to do is they want to move the 2 with the variable, but that's not how it works because the 2 is not technically tied to the x unless there's parentheses. So if there's parentheses around the 2x, then yeah, we're going to go ahead and move the 2 with it, but there's not. This 2 is just on the outside of the x. So if I wanted to change this to positive exponents only, I would rewrite it like this. So only the x will move to the top and get that positive exponent, but the 2 will stay down on the bottom because it didn't have a negative exponent. It was just by itself and happened to be standing next to something with a negative exponent. All right, so that is also a mistake that I see a lot of times that students will make. So just kind of keep that in mind. All right, next up we have the multiplying similar bases. So if your base number is the same, when you multiply, you're going to add your exponents. So for instance, we do this one a lot. So if I have x squared times x to the first, this is going to give me x times 2 plus 1, which is x to the third. So x squared times x is x to the third, because what we're doing is we're adding those exponents. All right. So that's your multiplying similar bases rule. The next one is division. All right. So if we're multiplying, when we multiply bases, we add the exponents. Then when we divide the bases, we subtract the exponents. All right. So these two rules kind of go together. Right. Ooh, not that one. These two. Those kind of go together, all right? Just one is multiplying, so you add. The other one is division, so you subtract, all right? And you always subtract the one from the top minus the one on the bottom. So if I have x squared divided by x cubed, all right, so I gave us kind of a hard one for this little thing right here, but that's okay, all right? What you're gonna do is you're gonna say, okay, that's x squared, or not really x squared, x to the power of 2 minus 3, so you subtract. And the number that's on top is always the one that goes first. This is going to give me x to the negative 1, which if we don't want negative exponents, we would then write like this. X, 1 over x to the first, or 1 over x. All right, what some teachers will tell you to do is subtract the biggest number from the smallest number and then keep it wherever the bigger number is. So using that technique, if we were to look at this x squared over x cubed, you just subtract big from small. So we would do 3 minus 2 and get 1, and it's going to stay wherever you had the largest exponent, so the x to the first stays on the bottom. All right, we did the same thing, we just kind of did it using the property instead of kind of like the trick method, but both of those are perfectly fine to use. However it makes the most sense in your brain, that's what you should do. All right, and then last but not least, we've already talked about this one if you've watched the simplifying radicals video, but when you have a fraction exponent, it actually means that you have a radical in your problem. All right, so just for good measure, since we did kind of an example for each one of these, I'm going to show you what this one would look like in case maybe you missed it in our last video. So if you had x to the power of 3/4, for instance, that would be the same as having the fourth root of x cubed. All right, main idea is the number on the bottom goes to the outside of our radical, and the number on the top of the fraction stays with our variable and goes underneath the radical. All right, so you just have to remember where each piece kind of goes. All right, so those are our rules for exponents. Those are the only rules that we have. Now I'm just going to do a couple examples where we have like all of the rules kind of mixed together and try and see if we can kind of figure out the right way to do our problems. All right, so I'm going to scroll down and give us some room over here. There we go. And I'm going to do a little zoom in just because it makes it a little easier to see. Okay, maybe one more zoom in. There we go. All right. So for the first one, it doesn't matter in what order technically that you do all of this stuff. I'm just going to show you the most, I think, simplified way to do it. I don't know. It's the way that makes the most sense to me. All right, so I like to first deal with anything that has a 0 exponent because those are easy. Ooh, I have the hiccups, I'm sorry. Something raised to the power of 0 is just 1. So in this problem, I have an entire parentheses being raised to the power of 0. What that means is literally this entire bottom piece right here is just 1. So I'm now going to rewrite this as 6x cubed y to the negative 4, negative 2, all over 1. Okay, now from here, you have two different techniques that you can use. You can apply the exponent first, or you can choose to make that exponent positive first. It doesn't matter which one you choose. I'm going to go ahead and use my product rule where I'm raising an exponent to an exponent. So I'm going to distribute my exponent into the parentheses. Now, if you did watch that last video, you saw me talk a lot about don't distribute the exponent into the parentheses. That only is true when you have a plus or minus sign inside your parentheses. Since this is all multiplication, it's fine to go ahead and multiply or distribute that exponent into my parentheses. If this was 6x cubed plus y to the power of -4, then I could not do that. I couldn't just distribute my exponents because then it becomes a different problem. All right, but since this is all multiplication, I can go ahead and distribute this. Now, when you do this, you want to make sure that you give everything the exponent on the outside of the parentheses, including the coefficient out front, the number out front. All right, and a lot of times people forget that. So everything is getting raised to the power of -2. So when I rewrite this, it's 6 to the power of -2, x to the power of, now I multiply my two exponents, so 3 times -2, which is -6. And then y, and again, I multiply my exponents. -4 times -2 is +8. And it is all technically over 1, right? Okay, next what I want to do is I want to go ahead and I want to get rid of those negative exponents. To do that, I'm going to use that property that says I just kind of do the inverse or reciprocal of it. So if I have 6 to the -2 at the top, that means I have 6 to the +2 down on the bottom. So I'm just going to draw my division. So 6 to the +2 on the bottom. All right, if x is to the power of -6 in the numerator, then to make it a +6, I'm going to move that down to my denominator. So I have x to the power of +6. Now, y to the 8th is already positive, so it can just stay on the top. All right, the last thing that I'm going to do is I am going to square the 6. So 6 squared, I do know what that is. 6 squared is 36. So for my final answer, I have y to the power of 8 over 36 x squared. X to the 6th. Now let's roll this down a little bit. There we go. Okay, this is my final answer. Can't do anything else, so I'm just going to leave it just like that. Okay, moving on to the second one. All right, so for this one, I don't have any 0 exponents. Bummer, because that is much easier. All right, we got rid of that whole denominator in that first one. All right, but I do have some things that I can go ahead and take care of first. So my advice is if you have multiple variables that are the same in either your numerator or your denominator, to go ahead and combine those first. So in problem number 2, I noticed that I have a y squared and I have a y to the -3 both in the numerator. I also have two constants. I have a 2 out front, and I have a 3 being multiplied to my y in the middle. So I can go ahead and just kind of multiply those. All right, so like I said, first I'm going to take this 2 and this 3, and I'm going to multiply them. 2 times 3 is 6. All right, I only have one x in my numerator, so I can just leave it as x cubed. But now I'm going to multiply y squared times y to the -3. And remember, if you're multiplying it bases, you add their exponents. So you end up with y to the power of 2 plus -3, which is going to give me y to the -1. All right, all over. And then in my denominator, there's nothing I can combine there. I only have one of each thing. So I'm just going to leave it as x to the 4th y cubed. Okay, so depending on who you are and what you feel more comfortable with, this next step might be a little bit different for you. For me, I like to deal with the negative exponents first. So what I'm going to do is move the y to the -1 down to the bottom. So I have 6x cubed up top, and then I have 3x to the 4th y cubed times y to the +1 on the bottom. All right, so I like to make all of my exponents positive if I can. That usually is my next step. Okay, so from here, I can really just simplify my problem. All right, So I see that I have a 6 divided by 3, so 6 over 3, and I know that 6 over 3 simplifies to 2 over 1, because 6 divided by 3 is 2. So the first thing I'm going to do is change that to a 2. All right. Now I'm going to use my division exponent rules. So I have x cubed divided by x to the 4th. So I'm going to go ahead and subtract those exponents. And since 4 is the larger number, it is going to be a positive x to the 1st on the bottom. All right, you could do this in a couple steps. Remember we said if you do it with the subtraction, you just subtract top from bottom and then it stays it's in the top, but then we would have had a negative exponent, so I just kind of already moved it to the bottom. All right, so just subtract, and like I said, the quick way to do this is when you subtract your exponents, it stays positive wherever the larger exponent is located. All right, and since 4 is bigger than 3, then it stays on the bottom. All right, for the y's, all I have to do is add my exponents because we're multiplying. So this becomes y to the 4th. All right, and that is actually it. That is my final answer. All right, so I have simplified everything and that is what we get. All right, so that is simplifying with exponents. I hope it was helpful. Yeah, that was the only video for today. Hopefully that will get you guys through your homework for tonight. But yeah, until next time, bye guys.